That one. All right. So what I've got is a little device here, and this thing is leveled using highly sophisticated technology. I'm lining it up with the cabinets in the back of the room. There we go. And what's going to happen is I'm going to flip the switch. This thing is a solenoid, which is just a fancy word for a magnet, and it's going to suck that little piece of metal right into the middle of it. Okay, these are the things that your car uses to lock and unlock your car, right? And they're just really cheap, and they can operate thousands of times without malfunctioning. This one here, though, what it's going to do is it's going to eject this ball sideways. This one's going to fly to the side and land here. This one, it's just going to pull the pin out, and it's going to fall straight down. And the question is, of course, assuming I can get this thing level, which will hit first? Will the one that shoots out hit first? Or because it moves out? Or are they going to hit at the same time? It doesn't look level to you, but I think it is. All right. This is a very important principle. Are you ready? Now, I do have super slow-mo, so we are going to look at it in super slow-mo, okay? But, okay, we also can use our ears, right? We'll do what the first base umpire does, right? If we hear, what? If we hear ball in glove before foot on bag, the runner's out. And if, what? If we hear foot on bag and then ball in glove, then they're safe. You just listen to the two sounds, right? Can't you? I think that's what they do, right? Okay, so
They use their eyes too.
So we're going to listen. If we hear click, click, then they landed at a different time. And if we hear click, if we hear the mono click, right, then they... Are we ready for this?
Yeah.
What do you guys think, though? Is it good same time, or...
That one's gonna go first.
This one hit first?
Yeah.
How many say this one's going to hit first? How many say this will hit first? The one that fell straight down, more direct path. How many say at the same time? That's a strong majority. Okay, let's just try. Let's try. Are we ready? Listen, listen, listen. Shh. That was pretty close, wasn't it? I actually heard a separation. Let's get it. Let's see if I can get it more level. Oh yeah, it's not level quite here. I'm leveling the spheres. All right, let's listen again. Pretty close, isn't it? Yeah? It's pretty close. Where'd the other one go? Where'd he go? Oh my God, come back. All right. All right. Yeah, all right. Let's watch it on super slow-mo now. You guys ready for this? Okay, here we go. Whoops. Off. Okay, here we go. Super slow-mo. Now, if you look at them, they both have in the vertical direction. In the vertical direction, the story's the same, correct? Neither one of them had a vertical velocity. It was 0, right? Okay? Well, I paused it. Okay. Neither one of them, right? The only difference is this one was projected off to the side, right? But they both had the same distance vertically, right? They both have the same acceleration vertically. They both had 0 velocity to begin with vertically, right? So at any given instant in time, they're actually the same distance above the ground. The only difference is that that one's moving off to the side, right? And so they... And they hit the ground about the same time, yeah? Yeah? Give a little applause. Very good. All right, now. This is... This is our very... This is our very important principle. PLE principle, right? The PAL is the, like Darren Bernard. Yeah? Or like the principal reason behind this, right? Oh, that's very confusing, isn't it? Okay. Horizontal motion does not affect vertical motion. There is no effect. Okay, so just a little kids always mess this up when they're writing their research papers in the second year. There's affect in science and effect in science. Come back. Come back. You're mine. All right. Okay. Affect is the transitive verb. Transitive means it takes an object, okay? This affects this, okay? The verb is almost always A-F-F-E-C-T in science, right? The noun, that's a noun, right, is almost always affect, yeah? There are exceptions to this, okay? But almost always, right, that's what we're talking about. Now, that is a very important principle, and this makes our life so easy. What this means is that we can solve horizontally separately from vertically. Horizontal, we can do a totally separate suvat. Vertical is a totally separate suvat. The only thing they share is time. They both share the non-vector, which is sort of a weird thought, right? The one thing that's not a vector, which is time in this case, right, in our classical sense, right, is the one that they share. In other words, that thing moves to the side for the same amount of time that it moves down. Does that make sense? Yeah, well, it'll make sense. I'll show you this in a sec. But before we do that, I have to do another demonstration that's even more fun. Okay? Are we ready for this?
Are you going to light it on fire?
No? Maybe. All right. So, you guys maybe had one of these things when you were kids, played with it. I know I had one. Okay? This is a little cart, and it's quite heavy.
Are you dragging?
No, I'm not. I'm going to toss it down right here, right? Okay. Now, I'm going to hold this thing still, and if I pull the pin out with it held still, Maggie Richter, okay, the ball is going to go out of the thing. Come on, come on. Okay, let's try it again. I'm going to rewind. Okay, go back. Okay. Why does it do that? Okay. If I hold it still, it goes up, and it lands back in the cart. Yes? Or at least it should. Sometimes it apparently goes off to the side, right? Now, the question is, what will happen if I take this and give it a shove so that its momentum carries it forward, pulling the pin out, right? Will the ball land behind the cart? No. Will it follow along with the cart and land in the cart? Or will it land before the cart? You either believe it'll land before the cart, in the cart, behind the cart. Before the cart, in the cart, behind the cart. All right, now that you've decided and had so long to think about it, how many say it will land before the cart? Raise your hand proudly. And that's nobody. Okay. How many say it will land in the cart? Raise your hand proudly. How many say behind the cart? We got a few. But clearly in the cart was a majority even in Florida, right? Yeah, there we go. All right. So, and that was like a super majority, wasn't it?
What?
That was like a super majority, wasn't it? Yeah. I think there's no need to even do the demonstration. No, a cleared majority. Wasn't even close, was it?
Do it.
You want to see it?
Yes.
Oh, okay. Oh, all right, I'll do it just this one time. All right, drum roll, please. There we go. Now, would somebody like to use our newly minted principal emotion to explain why it landed in the cart? Matthias is back there, right? Yes, Miss Granger. Yes, yes. Mr. Granger. Yes, it was already moving horizontally. I called you Hermione Granger, and I'm sorry about that. All right. No, keep going.
It was already in horizontal.
It was moving horizontally, and when it got shot up in the air, it continued moving horizontally. The fact that it changed its motion vertically did not affect its horizontal motion. Isn't that a beautiful explanation? Let's give him a round of applause. All right. Isn't that wonderful? Yes, now, I think as scientists, shouldn't we delve deeper into this phenomenon?